It is Carliza Canela. I'm hoping I'm pronouncing your name correctly. Also, an intern working with Dr. Maren Bixson at the City College of New York in the Neural Engineering department. And Carliza will be talking about the correlation between static and dynamic impedance. So in our first talk, we heard a lot about static impedance. Now we'll be talking about that in comparison with dynamic impedance during ECT. Take it away, Carliza.
Hi. Let's, wait a minute. There we go. Hey, thank you guys for the opportunity to speak about this. I will be talking specifically about the correlation between static and dynamic impedance during electroconvulsive therapy. So electroconvulsive therapy is decades old. It started in 1932, and it is currently cleared by the FDA as treatment for severe drug-resistant depression. And what it does is it uses a high-intensity current to elicit a motor seizure response in the patient. This high-intensity current is passed through two electrodes that are located on the head. I will specifically be speaking about the right unilateral placement and the bilateral placement, which are pictured below. So there are a lot of parameters involved in ECT, but two specifically are determined by the clinician. So the electrode placement is determined ahead of time. The pulse width of the current is also determined ahead of time. And the pulse width can be either 0.3 milliseconds, which is referred to as ultrabrief, or 1.5 milliseconds, which is referred to as brief. When the machine is turned on, after the electrodes are placed on the patient, a measurement called static impedance is taken, and that is taken at a current of 1 milliamp. During an actual treatment, when the therapeutic current is applied to the patient at either 800 or 900 milliamps, the impedance of the head or the resistance of the head to the current being passed is called dynamic impedance, and that's also measured. The charge is determined by an initial titration session. So because ECT has been around for so long, there have been many publications over the past probably like 90, 80 years or so. And so certain things have been established. Among those are that dynamic impedance is always significantly lower than static impedance. So dynamic impedance ranges in the hundreds ohms range, and static impedance goes from several hundred ohms to sometimes many thousand ohms. There hasn't quite been a relationship between static and dynamic impedance that has been established, but it also bears mentioning that static and dynamic impedance vary widely from one person to the next, and so for all of the data for a single person between sessions, their static and dynamic impedance can also vary. What the other two relationships that have been discussed in the literature are the weak reverse relationship between charge and dynamic impedance, and the weak direct relationship between age and charge. So when we were looking at this data, we had a lot of, or when we were looking at ECT, we had a lot of questions about how everything was related, and the relationship that emerged from the raw data from Sackheim et al. 2008 that was done at the Department of Biological Psychiatry at Columbia University was that there was this emerging relationship between static and dynamic impedance. And so what we have in front of us are just the raw data for the, actually not the raw data, but the average data for these 90 patients where we took their average static impedance, average dynamic impedance, and then you can see the full range of what the actual session by session impedances were through the error bars. So as you can see, the static impedance varies widely and the dynamic impedance varies a little bit more narrowly. And what we found was a statistically significant correlation, sometimes weaker, sometimes very strong. And we also looked at this data session by session. So we took each session as an individual point, as opposed to like the average of all the data for each person. And we looked at the relationship again, and again, you could see that there was sometimes a weaker relationship, but sometimes a fairly moderately strong relationship. We also looked at the data and its distribution among different subsets within the entire data group. So what we looked at was we compared RUL to BL, we compared females to males, and we found that RUL tends to have higher impedance both in static and dynamic, and females tend to have a higher impedance when compared to males. Then we also looked at all the other parameters, and we found fairly weak relationships in the things that had been highlighted by some of the past literature. And I don't think there's very much to say about that, so I'm going to move on. We were then curious to see if this is just like a fluke, right? Like, are these 90 patients was there something about the fact that it was single center, like Sackheim did all of the procedures, was there something about that was unique, or could this be seen in other subsets? So we looked at the data set from Sackheim et al. 2009, which the practitioners were different and the procedures varied slightly. And they were also done at 3 different locations. And you can see that even when the relationship is weak, it's still statistically significant. And I guess that's pretty much it. I guess the only thing I have to say now is that it's interesting that this relationship hasn't been pointed out in the past, considering how much literature there is, how many publications there are when it comes to ECT. And I guess that's everything. Thank you guys for your time and your attention. I appreciate it.
Thank you so much, Carliza.
Should I leave the discussion points up, or does it not
Yeah,
matter?
I mean, it does not matter. If you feel like that would contribute, please do leave it up. So I don't see any questions from the attendees. So I will, I have actually a lot of questions. So what is the implication, in your opinion, about the relationship between the static and dynamic impedance? Like, in practical terms, what does that, how does knowing that help us?
That's a really good question, because I've definitely thought about it a lot. I think the lack of variety within the data that is specific to dynamic impedance tells us that there could possibly be a stronger practical application for that. It also tells us that there are certain things about our physiology and our head anatomy that are sort of like, that are irrefutable, right? Like, if someone has consistently high static impedance, it doesn't mean that that really applies to anybody else. And when you're looking at how tissue variability changes, and, you know, because the tissue dynamics changes when the current is applied. So there are certain things that just can't be refuted, like, you know, the amount of fat tissue you have, the amount of skin tissue you have, and how that affects the impedance also will tell us how the current is shunted in the head, and whether or not that can actually elicit not just a motor seizure, but a whole brain seizure that will give you the response you want for the therapeutic advantages of ECT. But I hope that answered your question.
Yeah, it does. And it's, you know, it's definitely an open question, right? Like, because this was theorized, now there is good evidence for it, and hopefully people will use that. So, and also kudos for replication, like having that same type of relationship in multiple different sites. That's actually really great. But I actually had a question about something that is probably not your direct work, but the age-charge relationship. Why do you think that is slightly positive? And so as you get older, it takes a slightly larger amount of charge to elicit a seizure. Is that correct?
Yeah, the skin becomes more resistive. And
okay.
it also has to do with the way that the fat content near the skin changes as you age. And that's been largely discussed and proven by other papers as well. But the difference is so slight, in my opinion, that it didn't see it so strongly in this data, even though it was so consistent. So part of what allowed us to see the static versus dynamic relationship was the fact that the procedure was so consistent throughout, because it was the same person who was doing it and following everything to a T. And it allowed this to come through where normally it sort of didn't come through as strongly.
Makes sense. And so, but what about the variance within a session? And do you have any, have you observed any consistent changes in the static and dynamic impedance I assume that the static impedance measurement is also taken between each application of ECT, correct? And so is there any consistent trends in temporally across the session?
We looked at that, and actually, like, if you look at multiple stimulations within a single session, so that person is, let's say it's the titration session where they're having more than one stimulation. Sometimes, like 45% of the time, the static impedance drops dramatically on the second one, but sometimes it increases in like a lot more than I would assume, and sometimes it stays the same. So there's not really like a consistent relationship there. Although we did look at it, we assumed, we went in with the like assumption that it would drop, and we didn't see that, so that's why it's not on here.
Like people will start sweating, is that?
I don't know. I don't know what it is. I don't know physiologically like what happens, but it doesn't seem to be consistent with everybody.
All right, I'm still not seeing any questions.